Hi there, this is a video on transformations and modulus function. This is a revision exercise, basically looking at the two topics that have come up in chapter 3 from the Year 13 textbook. And I've got an example on the screen already where they've drawn for us the graph of y equals f of x. And it's obviously this quadratic curve looking like that. And they say draw the graph of y equals f mod x, and also the graph of y equals mod fx. And we've seen these two different types of graphs. This one I've talked about basically describing that as a reflection. This one is a reflection leftwards. So this reflection left comes about because of the mod x. And everything on the right reflects over to the left, and we lose the stuff on the on what was on the left. And so that's what's happened. You see, we've got this reflection left. Whereas the second one, which they haven't drawn for us, y equals mod f of x, what that does is it takes the stuff on the top and leaves it alone. But everything that was on the bottom bounces back. So you get a pitch like that. This one I would describe as a reflection upwards. So just be aware of those, and we're going to come on to that as well. So this first question, or PowerPoint slide, talks about, well, BODMAS or BIDMAS, whatever you want to call it. So I want you to be aware of when BODMAS can be seen to work and when it doesn't. So this first example, you'll notice there are three transformations. I've got one here, which is a stretch. I've got one here, which is another stretch, and one here, which is a translation. Now you need to think about which way it goes. So the 2 is a stretch going up and down. As it happens, it's a stretch upwards in the y-axis. Whereas the e to the 4 axis, that you can think of this as in the bracket, is a stretch left and right. And the last one is a translation, and it just moves it one up. So it's translation, so that goes one up. So what you'll notice is there are two things going up and down and only one thing going left and right. So we've got to be very careful. The two things that go up and down, we've got to get them in the right order. And on this question, because the two things are not in the brackets, BODMAS works. So you can look at that and think, BODMAS, yep, that's good. So that means I've got to do the times in, the multiplying, before the adding. So I'm going to do the 2 bit followed by the 1 bit. The last thing, the left and right thing, doesn't really matter when I do it. I could do it first, second or third, because that goes in the opposite direction. So notice my answer on this, please. Stretch parallel to the y-axis. BODMAS says multiply first, so that's what I've done. Followed by a translation of 0,1. I've then moved it up. These two must be in the right order. Has to be this, then this. And that's why I've written also there is a stretch parallel to the x-axis, scale factor of a quarter. That doesn't matter when I do it, because it goes the opposite direction. So that's, you can clearly see then that BODMAS works when it's not in the brackets, unlike here. So here I've got a 2 again. I've got an original graph of y equals log x, and I've got a 2 at the front, same as last time. Then I've got a log of 3x minus 1. So notice now this 3x minus 1 bit are both in the bracket. So let's just talk about it. This is a stretch upwards, okay? This one is a stretch left and right, and actually a stretch by a scale factor of a third. But this one is a translation left and right. Actually, it moves it one to the right. So we've got to get this in the right order. And when you write this out, I want you to be aware, because it's in a bracket, BODMAS doesn't work. If you try to do these two things in the order of BODMAS, you'll be wrong. So that's why I've said, first of all, we are going to translate it 1,0 first, followed by the stretch parallel to the x-axis, scale factor of a third. You'd think it'd be this one first and this one, but because it's in the brackets, it's in the wrong order. It kind of follows the same rule. If you remember that, you'll get these right. Also a stretch parallel to the y-axis. Well, this one could be done in any order. Again, this is just on its own. It's the only one moving up and down, so I do it whenever I like. So I've written it at the bottom. So just be aware of that, and we might come on to that in a bit. Describe fully the sequences of transformations that do 2 cos 3x. Well, this one's relatively easy. This is a stretch upwards followed by a stretch left and right. You can do them in either order. So I've written stretch parallel to the axis, scale factor a third. Yep, because it's in the bracket, so it doesn't do a 3, it does a third. Stretch parallel to the y-axis, scale factor of 2. Yes, it's outside the bracket. Either way around, doesn't matter. Second one, sine x onto minus sine of x minus pi. Well, this is a reflection, up and down. So that moves up and down, and this one is a translation left and right. Again, makes no difference which way around I do it. So I've written it's a translation by pi 0, notice it's minus, so therefore pi to the right, and it's a reflection in the x-axis. Happy with that. Third one, what's going on here? Well, now both of these are in the bracket. So both of these are, this is a stretch by a half that way, and this is a, well, it's actually a movement, a movement left and right. It's minus 1, so it goes to the right, but they are both in the bracket. So BODMAS doesn't work in the brackets. So I've written it's a translation 1 naught first, followed by the stretch second. And that is very definitely not either or. It has to be this one first and then this one. What's this one? So this has got 3 things going on. This has got e to the x goes to a half, that's up and down. E to the 3x, well that's a stretch left and right, plus 1 movement to the left as it happens. So in this example then, what we've got is the 3 transformations, 2 going in the same direction. So what order we do it in? Well, the half can be any time. I've said a translation minus 1, 0, that first, followed by a stretch parallel to the x-axis. Now I've actually then said followed by a stretch parallel to the y-axis. This one doesn't have to be followed, it can be. This one can be at any point. But the first 2 must be in that order. The final one then, it says tan onto this. Ooh, there's lots of things going on here. We've got a reflection, we've got a movement up, we've got a stretch by a scale factor of 2 and a translation. Now these 2 both go left and right. Now this one comes first, followed by this one. Of these 2 things, BODMAS applies, and actually this is like times by a -1. So this one must come first. The reflection must come first before the movement. So let's see what I've written. You can't see it all actually. A translation of minus 15 naught. So that's that one. First, followed by a stretch parallel to the x-axis. So that's that one. A reflection in the x-axis. That's that one. And then lastly, a translation, and you can't quite see it, translation 0, 1. And those 2 must be in the right order as well. So it's quite enough to be getting on with. A sequence of 3 transformations maps y equals log x onto that. Obviously we've got a complication, and I suppose this is best seen when you look at the graphs. Y equals log x looks like that. E to the x looks like that. You should be aware these are inverse functions in the reflected in the line y equals x. So I suppose first of all, to go from y equals log of x, I've got to go to y equals e to the x, and this is a reflection in the line y equals x. Now that's unusual to have a completely different curve, but it's not completely, I suppose. But once I've got this e to the x, what am I doing? I'm doing 2 different things. One's moving up and down, one's moving left and right. So I'm going to have a stretch followed by a translation, all the other way around. Oh, I haven't got the answers here. So I'll write it out. This is a stretch I'm going to do first, but it don't have to be parallel. That's in the brackets because it's up there to the x-axis. And it's a scale factor of a third. And then the -5 isn't in the bracket, so I can finish off with that. It's a translation by the vector 0 across -5 down. Let's have a look at this one. The diagram shows the point, the graph of this. This looks like quite a horrid graph, which crosses the x-axis at the point A. Okay, and the point B. Determine the coordinates of the point A. Well, this is the 0 line. This is when y equals 0. So if I'm going to do that, I better set this equal to 0. I'm going to do it up here. Minus tan inverse half x minus a third pi equals 0. Well, having the minus there doesn't really make much difference in terms of where it crosses. Move the tan onto the other side, I get a half x minus a third pi equals tan of 0. And tan of 0 is 0. So therefore a half of x minus a third pi equals 0. A half x equals a third of pi. Presumably x therefore is 2/3 of pi. So 2/3 of pi, well, pi is 3.14, so 2/3 is about 2, yeah, that's about right. Coordinates of b, well, b is when x is 0 on this line here. So all I've got to do is put 0 into this. This is y equals the minus inverse tan of 0, I can ignore, of a minus third of pi. And that's just crying out to be typed into a calculator. So it's a minus inverse tan, make sure I'm in degree, radian, sorry. Yeah, I am. Of a minus 1 divided by 3 times by pi. And I get 0.808. Now I'm not sure what if that's something I suppose it should be really, because a third of pi, I should be able to do that more precisely. But I'm just going to write 0.808 for the moment. It's 0.0808. It doesn't say it wants an exact point. I'm just going to do it exactly as well. Just think about it. I haven't looked at the answer on this. I suspect there isn't an exact answer, but there you go. Anyway, I shall leave it like that. Give full details of 3 geometrical transformations, which of course is what I'm really after, to transform y equals this into this graph. Well, this is a reflection. This is a stretch. And this is a translation. And of course, 2 of them are both doing it in the left-right. In the bracket, they're both going left and right. That's up and down. So in answer to this question, I shall write it up here because I'm running out of space. Number 1, I'm going to do, well, you think you do that, but you're going to do that. So I'm going to do the translation first. Translation. It says a minus, so it's going to go a third pi to the right, 0 up. Number 2, we'll have a stretch. And this stretch is parallel, obviously, to the x-axis because it's in the bracket, and because it's in the bracket, scale factor isn't a half, it's 2. And the last thing, 3, get rid of that, it's a stretch parallel now to the y-axis. Well, it's not a stretch. Well, it is. You could write it as a stretch. It's actually a reflection. So it's a reflection. It goes up and down, so it's in the x-axis. So there's my 3. There's another question here, which perhaps for you to have a look at. There is a part 2 which you can't quite see, and part 2 says it's reflected in the line y equals 0.5, and I think I'm going to end up having to do the second part of this lesson on a second video, because I eventually am going to get on to so that is where the modulus function starts. So I'll finish off this one question, and then I'll leave you the last one. So find an equation for the transformed curve. All right, and so I've got a curve. This is quite a gentle one, really, in comparison. I transform it so that it's a reflection in the x-axis. So part 1 will just say y equals minus sine x. It reflects up and down, so the minus is there. Part 2, which is reflection in the line y equals 0.5. Now to reflect on the line y equals 0.5, that's there. So I think what I'm going to have to do is, because all I've got is a reflection, I think I've got to do, would something like this work? I've got to reflect it first, and then I've got to move it up. And I haven't got time to properly think about how much I need to move it up. I think that works. So here's the extra question, and I'll do another video for you in a bit.